Good morning, good afternoon. Welcome to the first in our series. We're going to get started because we only have 30 minutes today. Um, my name is Aparna Ray, and I head up operations at Planette AI. And we're really excited to have a weekly series where Dr. Hansi Singh and other experts walk us through what is happening in the world of weather. And um, I'm going to invite you, as we're getting started, to turn on your camera if you want. It's really, really nice to see folks rather than just seeing these little black boxes as we're having this conversation. We've also noticed that everybody's name as you entered, or most people's name as you entered, was Leo B. So you're welcome to rename yourself. And then when we call in on you, we can actually use your name. So just one last little bit of housekeeping. As you're in this webinar and questions come up for you, like you want clarifications on something, or you have a question related to how the weather outlook is going to have an impact on your industry or your work, go ahead and put it in the chat, or you can chat me directly. You can direct message me, and I'm going to keep a tab of all of the comments and questions so that we can ask those to Dr. Hansi Singh at the end of the session. So without further ado, Hansi, going to pass the mic to you.
Thank you so much for that warm welcome and introduction, Aparna. So, just a little bit about me to start. So, I'm an Earth system scientist. I used to be a professor. I used to be a scientist at the US Department of Energy Office of Science in the Earth Sciences Directorate. And my co-founder, Dr. Ramea, and I decided to build Planette AI so we could take some of those findings from the scientific world and really bring them into the real world for folks like you to be able to make decisions that are more informed in whatever your industry is, including finance. So, as you know, climate change is altering seasonal patterns, it's heightening volatility in many places. And so, weather information is going to be really critical for helping all of us adjust to and find opportunities in the new world that we've created. So, this webinar is the first in a weekly series. Next week, I'm really excited to bring in our stratospheric expert, Dr. Aiden, to speak about cold snaps with me. And then the following week, we will talk about the ski season because I know many of us are really excited by ski seasons. So, stay tuned for those. So, to begin, just a teeny bit of background and a little bit of myth busting about how long range forecasting works. So, traditional weather forecasting, which is, your 10 to 14-day outlook that you get on your phone, this relies on atmosphere only models. The atmosphere has a 14-day memory, a couple week memory, and so this is why these forecasts are only effective up to 14 days. If we want to predict weather beyond the 14-day window, we really have to use a much more comprehensive modeling framework. And these are our Earth system models. So Earth system models include not only the atmosphere, but also include the ocean, ice, and land surfaces. And these components, ocean, ice, and land, have much longer memories than the atmosphere. In fact, the deep ocean has centuries of memory. And so this is what allows us to be able to predict weather beyond the 14-day time horizon that you're used to. Now, note that these long range forecasts, they are not day to day, but they can be week to week or month to month or season to season. So what this means is, let's say, you have great plans for Christmas, like many of us do, and you say, what is the likelihood that I'm going to have a white Christmas? Well, I can't tell you on December 25th, will it snow? But I can tell you these are the weather patterns that we're going to see this December. And this is the likelihood that these weather patterns are conducive to having a snowy Christmas. So we can get a lot of insights from these long range forecasts, but they are not magic. They do not tell us, the weather on a precise day next year. So I wish I could do that for you, but I can't. But let's go through what I can do for you. So I want to begin by looking over the next 6 months at some key modes of variability. So these are factors, large scale global factors that will be impacting the weather over the next 6 months. So our long range weather outlooks really depend on understanding these particular modes of variability. So today I'm going to focus on four. The first is El Nino, or the ENSO index. And this index currently is in neutral conditions and is expected to be in neutral conditions through spring of next year. The second is the QBO. So the QBO is a quasi-biennial oscillation, and it is currently in a negative phase, and it is projected to be in that phase for the rest of the year and into early next year. Then I will talk about the MJO and particularly how it helps us predict into October of this coming year. And then I will talk about the North Atlantic Oscillation. It's projected to be in its positive phase for the next 6 months, and it gives us some great predictability for what we can expect in the winter and early spring. So let's start with ENSO, which is kind of the least interesting of all of these indices. So the ENSO index, we project that it's going to be in highly, just very neutral conditions over the next 6 months. And I've seen, maybe there's a teeny tiny probability of a La Nina. I think that is pretty small. We're seeing, what looks like less than 10% maybe in January. I think most of the bets should be on neutral conditions. So what does this mean? Well, it does not mean that there's not going to be volatility. That means that there's just going to be volatility that can't be predicted using this mode because this mode is stubbornly going to be in neutral conditions. It also means that certain regions of our planet that are very driven by this mode of variability, so that includes areas in tropical South America like Peru, Brazil, Ecuador, Venezuela. These areas usually get a lot of predictability from the ENSO index. Because this index is in neutral, we might expect a little bit less predictability than we're used to over these regions. So keep that in mind. But the good news is that all of the other modes I'm going to talk about have some great predictability signals. And so I'm going to go into those next. The one that I'm going to go into next is the QBO. So the QBO is this weird mode that lives in the stratosphere. It essentially tells you about the direction of the winds in the tropical stratosphere, and it flips direction every couple of years. So the QBO just recently flipped direction into its eastward or negative mode. So this has some really important implications for predictability. First of all, when our QBO is in an eastward mode, this strengthens the MJO. The reason why that matters is because the MJO has huge impacts not only in the Asia Pacific, but also the signals from the MJO actually travel across the Pacific Ocean through waves and literally, and these are atmospheric waves, not ocean waves, atmospheric waves, though there's another type of ocean wave that's also involved, but we don't need to get into the nuts and bolts of that. So essentially, these travel all the way across the Pacific and they impact the weather over North America and South America. And so when the MJO is really strong, we expect really nice subseasonal predictability signals propagating across the Pacific and giving us really great insights from, say next week all the way to 6 weeks into the future in terms of what we can expect on those time horizons. So we'll talk a little bit more about the MJO in the next few slides. The other reason why this eastward QBO is so exciting is that when we have an eastward QBO, this means that we are going to have a weaker polar vortex, and a weaker polar vortex lends itself beautifully to sudden stratospheric warmings, and those then can project onto the surface as unexpected cold snaps. So this potentially is going to be a highly cold snap filled winter thanks to the eastward QBO that we're going to be seeing throughout this fall and winter and into the spring. So let's look at some implications, particularly now of the MJO. In terms of the MJO, what we see, first of all, is that there's a really warm Tibetan plateau. And for the month of October, the MJO is expected to be in a phase two. And so that means that there's going to be a ton of precipitation over South Asia that's associated with this. And so this corresponds to like a much stronger than usual late season monsoon over this region. We also see some related impacts over Southeast Asia, though most of the impacts really look like they are over South Asia. So please keep in mind that there are a ton of significant ports and industries within these areas. So these include automobile manufacturing, these include textiles, these include household goods. And so when you see pretty extreme precipitation predicted for weeks and weeks, keep in mind that this is a great environment for delays and disruptions in supply chains that move through this area and depend on goods from this area. The second interesting area that I just wanted to highlight, marginally related to the MJO, but is consistent with an MJO phase two, which we're projecting in October, is precipitation over Taiwan. Over Taiwan, it appears that we're going to have some pretty strong precipitation, pretty wetter than usual conditions in October. However, as we move through November, December, and early next year, Q1 of next year, we see that they are drier than usual. Note that this island has very little water storage capacity. So just because you get one significantly wetter than usual month does not mean that that can adequately account for the longer term drying trend in this region. So what we are keeping an eye on is that longer term drying trend and any impending droughts over this region. So right now, this region doesn't look too bad, but we do think that there is still in the long term conditions to keep a lookout for. So we'll continue to do that in these weather outlooks. And as you may know, Taiwan is a center for semiconductor manufacturing, which requires a ton of water. So this is why the precipitation outlook is so critical over this region. So no supply chain disruptions as far as we can tell for now, but the long range outlook is not looking good. The final thing I want to go over in terms of the MJO is those cross-Pacific teleconnections, particularly relating to MJO Phase 2 and impacts on precipitation over Florida and Mexico and Central America. So what we are seeing is significantly enhanced precipitation over Florida and southern Mexico, and parts of Central America. And so note that these are pretty important industrial centers. There's a lot of manufacturing, there's a lot of ports. So keep that in mind over the next few weeks in terms of thinking about supply chain disruptions and manufacturing disruptions and potentially delays in the stock of certain goods that are manufactured in this area, because it does look like a significant amount of precipitation coming up in October for these regions, unseasonably large. So now I'm going to move on to the last phase of variability that I wanted to talk about, and this is the North Atlantic Oscillation. So this is a mode that lives in the North Atlantic, and it determines weather patterns throughout Europe, North Africa, and North America. So we believe that the North Atlantic Oscillation is predominantly going to be in its positive phase over the next 6 months. Now, if we do get a sudden stratospheric warming, that can sort of briefly flip this into a negative phase. But currently, the sort of fundamentals are pointing towards a positive NAO for the next 6 months. So here's what this means. Some pretty exciting things for North America in particular. So notice that over North America, we see a colder than usual Canada, shown in blue, and a warmer than usual US, shown in red. And so what that means is that these conditions really enhance the likelihood for stormy weather over the US into Q1 of next year. So this means that it might be a pretty active winter in terms of winter storms. Now, if we look at the other side of the Atlantic, particularly looking at Scandinavia, Northern Europe, we see warmer than usual conditions. And then if we look in at Southern Europe and North Africa, we see cooler than usual conditions. So once again, that is a very canonical positive NAO pattern. And so, just like North America might see more storms, these conditions in Europe are in fact conducive to potentially less stormy conditions than usual. So, one thing to really keep in mind, you're seeing a lot of blue here. There might be this question of like, oh, is global warming real? Is our planet really warming up? Well, these are all blue relative to what we use is a 2020 baseline. And it's a baseline, it's a climatology centered around 2020. So yes, we can have years that are colder than 2020. We can have regions that are colder than 2020. But in general, our overall trend is still warming. But even within that warming trend, there's a ton of volatility, and these large scale modes of variability can tell us a lot about what to expect in terms of that volatility over the coming months. So finally, I want to get to cold snaps. So as I said, even though these temperatures look warmer than normal over much of the US this fall and winter, the background conditions, the fundamentals really favor cold snaps. And this is because of, as I mentioned, the negative QBO. And, we are also going to be in conditions where the US is warmer than usual. So any unseasonably cold weather is going to feel even more extreme under those conditions. So keep that in mind. There's going to be potentially a lot of volatility. Note that as soon as we get a sudden stratospheric warming, which usually precedes these cold snaps, we get up to 30 days of predictability from those. So, what we're going to be doing is keeping a really big eye on the stratosphere. And next week, I will be having Dr. Aidan Jaramillo Sweeney, our resident expert on the stratosphere, on this call. And we will go over the physics of stratospheric warmings and talk a bit about cold snaps, the outlooks, and what you can expect this winter. If you're interested in learning more about the models that we are using in order to be able to produce these weather outlooks, please just email me, Hansi at planette.ai. I'd love to chat with you and tell you more. You can also follow us. You can follow me, you can follow Planette on LinkedIn, where we're always trying to provide insights on links between weather, climate, and the businesses that matter the most to you, businesses and industries that matter the most to you. And yeah, we're looking forward to hopefully seeing you at next week's webinar. Thank you so much.
Thanks, Hansi. All right. We have 10 minutes for questions that have come up for folks. I want to start with the question that Stephen has in the chat. He says, I thought the polar vortex would drive cold snaps. Can you explain why less probability of a polar vortex would result in more cold snaps? And does this predominantly impact the mid/northern US?
Absolutely. So, when it comes to cold snaps, it's really important to remember that the polar vortex always exists. Some years the vortex is really strong. Those years we usually do not expect cold snaps. In years where the vortex is less strong, it's more likely to suddenly become wavy and start to project onto areas, say the northern US, sometimes even, dipping further down into the northern US. So, given the fact that our QBO is in that negative or eastward phase, these are ideal conditions this winter for cold snaps because that polar vortex is going to be weaker than usual. So I know that seems weird and maybe counterintuitive. A weaker than usual polar vortex lends itself to sudden stratospheric warmings and cold snaps. But you can just kind of think about it as that when it's really strong, it doesn't break down. Whereas when it's really weak, that's when it breaks down and sort of you get these huge waves in the jet stream and you get these unseasonable cold snaps.
Thanks. Stephen, other questions that are coming up for you? Did Hansi answer them?
No, thank you. It's very helpful.
Yeah.
Awesome.
Yeah.
Great.
Um, Other folks, questions that are coming up for you, you're welcome to unmute yourself. And yeah, we're happy to, I shouldn't say we, Hansi would be happy to answer them.
I am very happy to answer questions.
All right, folks. If you don't have questions or you don't feel comfortable coming off of mute or putting them in the chat, we want to thank you for being here. We're going to be back next week, Wednesday morning, 9:30 a.m. Pacific. We're going to be diving a little bit deeper into cold snaps. I encourage you, I put a link in the chat to next week's webinar. It's going to be another short one, 20, 25 minutes, just a little bit of a download. If you have questions, you're welcome to email Hansi. You're also welcome to put it in the registration, and we keep track of those as well. And yeah, once again, thank you for being